Hello students of 6th semester. I am Professor Rajesh Kale, Workshop Superintendent, MIT Polytechnic, Kothurud, Pune. Today we are going to study in this slides about automation, which is your second unit outcome. It is interpret the automation in mechanical industry, and the topics that we have to cover in this particular unit outcome is what is the need of automation and what are the basic elements of automated systems. So the key takeaways are need of automation and basic elements of automation. What is automation basically? It is a technology by which a process or procedure is performed without nominal human assistance. So human assistance is not required. For example, you can take autopilot mode of aeroplane, or you can take driverless car. You are sitting in that car, you are not doing anything, you have just sat in the car and the car has detected that somebody has sat in the car. Depending on what kind of level of intelligence your car has, you start the car and the car knows from where you have to go. Suppose you have started from home, you have to move to office, you put the data, you give the input data to that system, and then the car will take you. So that becomes a driverless car, though the driver is sitting in the car but he is not operating the car. That is why it is coming in the category of automation. Why need of automation is there? To satisfy customer demands, because these days customer are demanding a lot of things from a lot of products to the manufacturers. So and that too at premium quality and optimum cost. So to compensate this criteria, automation is required. So to satisfy customer demanding premium quality products and service that can be only be supplied by high level of productivity, following are some of the important points due to which automation is needed in industrial workplace. First is globalization, the second one is productivity. I would increase the ratio of productivity. Then comes industrial automation. Then comes reduce worker fatigue and effort or labor intensive operations, prevent product or material from being damaged or destroyed, prevent non-conforming product from shipment, which will ultimately save my money, and that are the parameters that are important for application or need of automation. Now comes the second part of the topic, that is elements of automated system. So there are three basic elements of automated system. You can see from the diagram itself, it is very clear that any automated system will have the following. First is power, the second is program of instruction, the third is control system, and the last one is nothing but what you achieve is a process. So there is a relationship between them. So power source in my case will be electricity. As far as everyone knows, we use electricity for everything in our day-to-day life, whether it be an industrial scenario or home or anywhere else outside. Power is required to drive the process as well as to control the control systems that are mounted in that particular system. Program of instructions, control systems are there. These executes the program of instructions. So there are two types of control systems. One is a open loop control system and the other one is a closed loop control system. So closed loop control system, we'll discuss about closed loop control system. It is also known as feedback control system. In this system, the output variable is compared with an input parameter, and any difference between the two is used to drive the output in agreement with the input. That means what it basically means, what it comprises of. It comprises of an input parameter, a set point represent the desired value of output variable, actual value of parameter, sensors. A sensor is used to measure the output variable, and close the loop between input and output. It performs feedback function. There are two states. It starts with input, it ends with output. So in between what lies, there lies a feedback function. There is a controller which compares the output with respect to the input or the set value that is there in comparator, and then error is calculated. Either error could be positive or it could be negative, and that according to that the changes are made in the system, and then the revised data is sent for the further machining tools. Actuators, the adjustment being done with one or more actuator, which are the hardware devices which test the physical carry out physical testing, control actions such as electric motor, cylinder, etc. So actuators are actually actuating the electric motor and cylinders that are installed in your setup, and that becomes the hardware part of your system, right? So the next part will be what is closed loop control system then. So closed loop control system is somewhat like this. It is having, I'm showing you a diagram of CNC milling machine. CNC milling machine is there, and then there is an input, there is a controller, there is a control signal being generated to the process starts and the output is generated. If there is an error in output, the same element will be sent through feedback system. Measuring element will measure the value, generate the error, the value will go to the controller. From there, controller will initiate the error part, and that will be then reorganized, or it can be corrected, and then corrected value will be then converted into corrected control signal, and then control signal will carry out the processes accordingly. So here the losses side are less. You don't want to stop money. There is you don't stop machine. You don't have lost time. You don't have manufacturing lost time. No setting lost time is there. The jobs that are being produced are produced with optimum tolerances and optimum precision or accuracy that is as required in part drawing or job drawing. So as a whole, it is not creating any problem. If some activities are not going as prescribed, the system will give you an error signal, and according to that you can make changes, edit it, and then resend it, so that they can give you best results with best quality and least cost or optimum cost. Now, all CNC systems are falling in this category. Then comes the second brother, is open loop control system. In this there is no feedback loop. You can see the diagram. From diagram also it is very clear that there is no feedback loop is missing in this particular setup. So any lathe machine, any conventional lathe machine, any conventional milling machine, any shaper machine, any welding machine that are coming in the category of open loop system, they are not giving you any feedback. You have to stop the machine, you have to check the diameter, and again take a cut. If it is undercut, then there is an issue. You can reject that job. If it is overcut, you can cut it in such a way that by setting the micrometer dial gauges, you can take that amount of cut from the workpiece material and then create the proper correct geometry as given in the part drawing. So in this case you have to do on your own, and there is no feedback system as such. So there is a disadvantage associated with this system. Every time I have to stop the machine, so stopping time increases. Every time I have to set the machine, so setting time increases. Manufacturing lead time increases, setting time increases. So market share time, market lead time also increases simultaneously. So many negative points are there that are connected to the open loop control system. Then comes the automation principles and strategies. So USA principle stands for understanding the existing processes, understand current processes in all details. You have to understand the process. That is, USA stands for, U stands for understanding, S stands for simplify the process, A stands for automating the process. So depending on what kind of experience you have in that industry, you can ask questions to yourself and apply the same principle to the existing system, so that you are converting that into automation. You are applying automation strategies and principles. So in principle category USA falls. USA is a principle. It is namely understood in such a way that you have to first understand the existing process there in the industry, then you have to simplify that processes, and then you have to automate that process. So automation principle is coming into picture, and what are the strategies that you have to follow so as to achieve the complete automation is nothing but the one you can see here is you have to specialization of operations you have to perform, combined operations you have to perform. Combined operations involves 2 operations to be performed on same machine, or 2 or 5 operations being performed on same machine, thereby reducing the setting time, thereby reducing the manufacturing lead time. So there are so many advantages associated with combining operations. This can be done in conventional setup also, it can be done on CNC machine also. Then comes the simultaneous operation, integration of operation, increased flexibility, improved material handling and storage, online inspection, process control and optimization, plant operation control, and of course the last and not the least one, that is SIM. That is SIM is standing for computer integrated manufacturing. This was the curriculum course in 5th semester of mechanical engineering students in ME5I. You might have studied that part, you know that part well. Then there are automation migration strategies. A typical automation migration strategy is the following. Phase 1 is used for introduction of new product for reasons already mentioned. Quick and low costing cost tooling to get started. Single station are automated to reduce labor and increase production rate. And third one is automated integration production system. You have multi-station automation systems, and serial of operations can be performed on automated transfer of works units between the stations. So this forms the third phase of automation migration strategy. Then there are merits associated with automation. First merit being increased throughput or productivity, improved quality or increased predictability of quality, improved healthiness, increased consistency, reduce direct human labors, installation in operation reduces cycle time. You can complete tasks where a high degree of accuracy is required. Then you can replace human operators. You reduces some work related injuries, replace human in tasks which are doing work in dangerous zones. You can perform tasks that are beyond human capabilities, for example size, weight, speed, endurance, etc. Frees up worker to take other roles. He has some time, so you can utilize that time for some other skill development purpose in the same shop. Provide higher level of job in the development, deployment, maintenance and running of the automated systems in the respective processes. So these are the merits of automation, some of the merits. And then of course, as there are merit, so there is the demerit side also. So demerits of automation are possible security threats due to increased relative susceptibility for committing errors, unpredictable or excessive development cost, high initial cost, displaces worker due to job replacement. So these are some of the demerits of automation. And then I have given you some questions, assessment questions. You can see which kind of questions can be asked. The one that are highlighted in red are the answers to the respective questions. Only a sample has been taken, and in sample I have taken only 2 questions. So what kind of questions can be asked in the respective topic in your exam, either unit test or mid-sem, unit test 1, 2 or the final exam. So thank you once again. I'll be signing off. Take care, stay healthy and happy.